Mastering A-Level Pure Maths Day 8. In this question, we are given a function of x, and we are told to show that the equation f of x equals 0 can be written as x equals the square root of 4 multiplied by 3 minus x divided by 3 plus x, where x does not equal minus 3. So the first thing we need to do is we need to set our function equal to 0. And if you take a closer look at the equation for x, you will notice that in the numerator, in the square root, we have 4 multiplied by 3 minus x. So when we expand the bracket, we have 12 minus 4x. So what we need to do is move the last two terms in the equation of f of x equals 0 onto the right hand side of the equation. And if we factorize 4 from the right hand side of this equation, we get this. So what we can do is factorize x squared from the left hand side of this equation and rewrite the left hand side as this. And after dividing both sides by 3 plus x, we get this. Therefore, x simply equals the square root of the right hand side of our equation. In the second part of this question, we are told to use this iteration formula with x0 equals 1 to find to 2 decimal places the value of x1, x2 and x3. So in order to find the value of x1, we need to substitute x0 into the iteration formula. And to 2 decimal places, we get a value of 1.41. And in order to solve for x2, we need to substitute x1 into our iteration formula, and we get 1.20 to 2 decimal places. And in order to find x3, we need to substitute x2 into the iteration formula, giving us 1.31 to 2 decimal places. In the final part of this question, we are told that the root of which our function of x equals 0 is alpha. By choosing a suitable interval, prove that alpha equals 1.272 to 3 decimal places. So the first thing we need to determine are the upper and lower bounds of our value of alpha, 1.272 to 3 decimal places. So we can represent 3 decimal places as 0.001, and when we divide this by 2, we get 1 over 2000. And in order to determine the upper and lower bounds, we need to add and subtract this value to alpha and substitute our upper and lower bounds back into our function of x to show that there is a change of sign. And given as there is a change of sign with this function of x, we can state that the function is continuous and alpha equals 1.272 to 3 decimal places. And that is the final answer.